Next part is only going to make sense to people who understand the Cooley-Tukey FFT. Recall the Cooley-Tukey FFT had, I guess, x0, x1 through xn over 2 minus 1, xn plus 1 through x2n, xn minus 1. And you took this guy, x1 with xn plus over 2 plus xn plus 1, and you added these, and you subtracted these. So you take this plus this over here, and this minus this over here. That is a Hadamard gate. And you need to add a factor of 1 over root 2 because, well, basically, the Cooley-Tukey, the discrete Fourier transform, you have a 1 over n on the inverse Fourier transform and a 1 on the forward Fourier transform. But you need to balance those out so that everything's unitary, and that means each level of each Fourier transform you need to divide by root 2. And then you did funny things over here that you multiplied all of these by what I think the engineering community calls a twiddle factor. And what's a twiddle factor? Well, the twiddle factor is all of these R gates. And you're only multiplying if both qubits are 1. And that's just corresponding to this thing, because this is when both qubits are 1, essentially. So that's a very hand-wavy explanation of how that corresponds to the Cooley-Tukey FFT. And if you don't understand the Cooley-Tukey FFT, you don't really need to know that. OK, so this is the Fourier transform.